Welcome to this talk, where we're going to be talking about the cloud. Ooh. So we're going to be talking about some ways to leverage the cloud, but hopefully in a more cloud agnostic way, meaning that we're going to try to find some ways to leverage the cloud without having too much lock-in. So we'll show some applications of that, and then focus specifically on serverless as well. So I'm Kevin Dubois. I'm a developer advocate at Red Hat, and with me is
I'm Daniel O. I'm Daniel O. And we are all Java champions. And then we develop advocate at Red Hat. So we're gonna try to spend a lot of time bringing more Java apps into cloud. And the ultimate goal is to make our Java developer happier. That's our goal today. Okay.
That was very beautiful. That was very beautiful. And do you see how we arranged the pictures? We're lovingly looking at each other. Yeah. So cute, right?
We just divorced.
All right, so in the first part here, we're going to talk a little bit about our journey to the cloud, or your journey to the cloud, and you know how it goes, right? Cloud computing, there's some nice advantages to leveraging it. You know, you can respond more quickly to demand because you can just create or ask for more resources. You can create new VMs or new Kubernetes clusters or more serverless clusters or serverless workloads. Or you can basically not necessarily have to worry about the infrastructure in terms of hardware, right? Because it's all managed by these friendly people living in the cloud. You get kind of high availability, disaster recovery. You can spread your workloads across different regions. You can have pretty high resilience thanks to that. And you can basically grow your applications in a manageable way. You don't need to immediately start with provisioning all these physical servers. Anyway, so we all kind of know that, right? It's nothing new. But it goes a little bit further than just putting an application in the cloud, right? You also need to think about, what are the developer tools that we're going to be using. You need to think about CI/CD and maybe automate it with GitOps. What about the networking, monitoring, and logging, and what container registry you want to use and everything. So you need some solutions for that as well, right? And so when we think about the cloud providers, so for example, AWS, they've got you covered, right? They have all these solutions, not just for your application, but everything around that, right? So here, you can see this is a screenshot that I took when I logged into AWS, and they have a whole bunch of services, which is really cool. And it's the same for Microsoft Azure, it's the same for Google Cloud, and then even for IBM Cloud, if anybody is using that.
Who are IBMer here?
Yeah, any IBMers here?
Yeah.
Let's see.
Okay.
All right.
Cool.
Yeah, so the downside though is that you're using these services from these cloud providers. Let's say we're going all in on AWS or on Azure Functions, but then maybe something changes. There's a regulatory change, like for example, I'm from Europe, so we have in the EU sometimes, they change the regulations of where the data may reside or something, and then this cloud provider may or may not be compliant with that, and then maybe we need to switch to a different cloud provider. Or maybe there's some outages that that happen. It's fairly uncommon with big cloud providers, but it does happen, and maybe it happens more, and you're not happy with them anymore. Maybe their prices change, or something that I've seen in my personal experience a few times. That you get a new CIO, and they're friends with this other company, and so you need to now change to this other provider. Maybe it's shadow IT, right? Some other team that is working with a different cloud provider, and now you need to support that too. There's many reasons why you might want to change between cloud providers, and that's where it becomes pretty painful, right? Because you have all these services that are very specific to one cloud provider, and now you need to switch, and everything is different. It's a major migration. And it's the same, right? It's the same for any of these cloud providers. They're very happy to lock you in. You can't blame them. But it is a consideration to take when you go into the cloud and start using cloud computing. So what's the solution, right? So is the solution maybe building kind of a hybrid or multi-cloud solution? Perhaps, but you may end up with something like this, right? Where you have some services running on AWS, and now you need a team that can support all that, because there's quite a bit of knowledge that you need to build up for working with AWS and all their services. And then the same with Azure, right? So you have some applications in Azure, now you need a dedicated team for that, and then same with Google Cloud, and so on and so forth. So it's not so ideal either, right? And so at some point, your organization and your platform engineers and everybody, they're getting a little bit frustrated with having to support all that. So that's why the first step, I think, is to consider how much of our applications and how much of our infrastructure, how much of our cloud infrastructure can we leverage open source with, right? So because if we're using open source, let's say, I took a screenshot here of the CNCF landscape, and I filtered it down to only open source projects on the CNCF landscape. And you can see there's quite a bit of services out there that you can leverage. It doesn't mean that there's maybe no company behind it that can support you. Red Hat will happily support you on a lot of them. But the nice thing is that you can use those services practically on every cloud provider, right? Especially Kubernetes, every cloud provider will support that, and then with additional services on top. So that will already help you a lot on your journey to the cloud, of course. So that's kind of a little introduction on cloud computing and how you can kind of limit the lock-in. But as we said, we were going to talk mostly about serverless. So
yeah,
pass the microphone.
Yeah, thanks for that. So let me really talk about the serverless journey. And a lot of people actually rare chance to use serverless. Thanks for adjusting. Okay. All right. So quick question. How many people actually have some experience to deploy your fantastic application in Amazon Lambda? Yeah, Lambdas. Oh, a few people. And what about any other serverless platforms like Azure or Google? Okay.
You were going to ask about IBM Cloud Functions.
Yeah, no, I'm not going to do that. Okay. So yeah, I just quick remind, I don't want to spend a lot of time, but I'm going to move to some quick demo with that. So serverless, a lot of people actually a little bit misunderstanding, I can only deploy my Hello World application or a very simple stateless application into serverless. Doesn't matter, Amazon Lambda, Azure Function, Google Cloud, but that's not true. So as long as you got some issue like resources or over-provisioning, under-provisioning along the Europe platform, you can turn into any workload into serverless. That is the beauty of serverless, and that is the ultimate goal of serverless. But the problem is for developers, hey, so how to change my app, how to evolve my app into serverless? Because I don't have enough time to learn something around SDK, API, and then some very complicated documentations. So that's starting journey, and there are some kind of good survey evidence why people are moving forward to serverless, because you can see that we are a lot of some over-provisioning workload. It doesn't matter virtual machine, bare metal, or Kubernetes. And then there are many kind of issues. For example, here's a good example, like some graphical diagram. So as you can see, so this is the recast, the blue line is actual your resources realization, but you cannot expecting how many resources like a CPU, memory, disk, or storage I need to consume at some point in the future. That's why you always increase your resources, not developer job though, it's more like a platform engineers, no offense. Then, so it's like a scale up and down, some pattern. And then when you go to serverless, it's like you don't need to worry about under provisioning or over provisioning because you really fitting into your demand. and then you don't have any incoming traffic. It's go down literally like a zero, nothing in there. Everybody happy, no spending money more, and then maybe good chance for increase your salary at a time. So when serverless came out almost 10 years ago, if I remember correctly, 2014, Amazon Lambda was released for the first time around the world. And then at a time, some of the limited application runtime supported the Amazon Lambda, including Java and JavaScript. But a lot of serverless people prefer to use JavaScript like a Node.js or Golang. It's a pretty lightweight, super fast, because every single serverless platform has some problem with something like a cold start model, which means serverless goes down, hibernate, zero, and then you got an incoming traffic. It's just start up automatically, magically, but this is not magic. So it takes a time, depends on your application and runtime. Sometimes it takes 3 seconds, sometimes it takes like 2 seconds or 5 seconds. But you know what? So I have 2 kids, and young, and then they not patient. If they're looking on some like a YouTube channel or Twitchy and they're waiting for 2 seconds, okay, I'm not interested anymore. Never ever visit again. So it's the SLA, you can say that, like 2 seconds, 1 second, whatever you call that. It's always a big challenge when you adopt the serverless. That is one of the challenge for Java as well, because Java was born like almost 27 years ago. And then at the time, Java was fantastic, running on a virtual machine and the JVM over the internet, which is so cool, and bytecode. But things change. You got to run Java apps, container or Kubernetes and serverless as well. And it takes a time way slower than like a JavaScript and Golang. So you're using Java? Okay, we don't go to serverless. But we cannot ignore Java developers at all. So that's a lot of effort coming out. We're gonna really talk about in showcasing like a new Java framework Quarkus as well. So this is literally one of the interesting story from Vodafone Greece. They were using Spring Boot and then running on Kubernetes. And then when you deploy Java app like a Spring Boot and Kubernetes, and then the beauty of the Kubernetes keep observe your application like a health check capability. Okay, I'm gonna keep looking at what you are doing, and then, are you ready to serve your application services? And if not, for the next 30 seconds or 5 seconds, I'm gonna kill you right away, and then kill the pod, and then restore again. That is the beauty of the replica on Kubernetes. The problem is inside the Java app, man, I need the time because I need to ready to serve my stuff for the next 5 seconds. But in the meantime, you misunderstand, you feel I'm died, but I'm not. So it happening over and over again. So they actually migrate Spring Boot to Quarkus, or looking for another runtime like a JavaScript or Golang. But another challenge for their company, they already good enough Java developers, a lot. They don't want developer learn something new, JavaScript. So let's say, hey, you are more than 10 years experience with Java, and then, okay, now you're gonna run Golang or JavaScript. Yeah, I'm gonna give you 3 weeks. Not gonna happen, right? So that's exactly happened in the Kubernetes for scaling. So Quarkus, how many people actually heard about the Quarkus before? Please hands up, everybody. Okay?
Everybody.
And how many of them actually give some chance finger on your keyboard with the hands-on experience on Quarkus? Okay, that's nice. We got a lot of to do today, okay, after this session. So yeah, let me quick just explain Quarkus stuff. So Quarkus is a Java framework, not compatible with a GraalVM or OpenJDK or even JVM. It's a Java framework, like a Spring Boot. But Quarkus put many effort into developer productivity. So we, just like I mentioned earlier at the start, as a developer advocate at Red Hat, we try to help developer life easier and make them happier. So Quarkus is one of our effort and achievements. So whenever you do application development as your daily job, like as a part of the iterative process, writing code, build the code, testing code, back to the writing code, testing code, and then run the code. It's every single time you're going to do the same thing in 10 months, 12 months, 12 years. And then, so Quarkus try to reduce some of the job as many as possible. Like we give them like a Quarkus dev mode is a live coding capability. You don't need to recompile, rebuild, restart application. We give it some continuous testing automatically whenever save the file, Java file, property file, it automatically kicking off your testing, unit testing, some of the stuff. It also standing container, like a test container automatically based on a test container, built-in test container, which means you don't need to set any compilation at all, like a zero compilation. We try to put more features and functionality to make developer life easier. So, and also we also care about the ops people because sometimes you deploy application of a platform, but okay, so we got some issue. Hey, developer, fix the problem right now in front of me in 2 seconds. So that's why people always have some argument between dev and ops. So if you could make a reliable application from your local, but also production, for example, Kubernetes. So Quarkus say sometimes, yeah, Quarkus Kubernetes native Java apps, which is make your application more cloud native and then Kubernetes native stuff. This is just some kind of stuff when you run Java application, behind the scene is happening, like annotation parsing, descriptor parsing, and then enable, disable some of the feature and module library. And then in the end, you're going to run Java application as a process and thread. We shipped all kinds of stuff except for running thread process and ship to the left side during the build time rather than runtime. That's Quarkus is faster than any other Java frameworks. Not only JVM, but also GraalVM stuff. You can also support, Quarkus supports checkpoint, like make a snapshot on JVM, way faster than like a normal running JVM. So some of the metrics, you can check.
OpenJ9? You guys use OpenJ9 now?
No, so Quarkus actually beats on Vertex and Netty. That is open library stuff. Good question. And then here are just some metrics, like because Quarkus already says supersonic subatomic, pretty tiny and super fast. And then so here are just some like numbers. You can actually check it out, this number, when you go to quarkus.io, the web page. And then I'm not saying what traditional Java apps here starting as, but I'm not going to say full sentence here. So that's why we got some pretty much improved a warm-up time compared to existing Java framework like Spring Boot, and then JVM, and then native, and then some throughput. So relate to Java and serverless. So let me just take one step back and then a little bit remind you the serverless journey. So like I mentioned earlier, serverless just happened and launched by Amazon Lambda 2014. At the time, it's a functions only everybody understood very stateless application, very limited runtime on Amazon Lambda. If you try to run like a long running process, you gotta pay a lot of money with your bill at the end of the month. So that's why some of the hyperscaler, like a public cloud provider, are starting support the serverless application, Lambda and Azure function, Google. Who knows this logo?
The one?
Yeah, not Facebook, unfortunately not. Yeah, yeah. You can reach out to us after the session if you know the answer. We could give you some swag.
Right.
Yeah.
Hint, you can go to the IBM booth and ask
yeah, it's too much, yeah. So here's just some code snippet how to develop Amazon Lambda. So you can go visit Amazon Lambda the documentation is some example with the Java. Okay, you can implement request handler to process some HTTP requests when you're coming down to your Amazon Lambda. So there are the known example. The problem is my business logic is exactly the same to store some data into my PostSQL or some sending Kafka topic. And then when I deploy Amazon Lambda, okay, this is a good example. And now 6 months later, okay, we're gonna go to Azure because Azure in Belgium is way cheaper than Amazon. Okay, we're gonna go to Azure, but same app, same functionality. Go for it. How do I do that? I need to read Azure documentation using different API, SDK, and the CLI. And then manager said, yeah, it's the same app. I'm gonna give you 2 days, and not gonna happen. So that's another example Kevin mentioned of the lock-in technology stuff here. So this is our goal. So Kevin and we are actually writing new book, the Serverless Java in Action. Give you some the fundamental example, but also advanced design pattern, make a cloud agnostic stuff. So once you create the Java app, once you could deploy any cluster, any serverless platform, but also treat it not hello world like a simple app. You can actually run serverless with a stable application or event-driven application, or you can also observe your serverless app like a Kubernetes and any other platform stuff. Yeah, stay tuned. We're gonna remind you at the end of the session here. So here's a quick example. Let me just go to demo and a quick show some example. Here's just some Quarkus CLI, how to get started to one of you Quarkus Funky. I love that name though. So Funky, I'm gonna make you use some funky dance today.
Nice.
Yeah, after 6 p.m. Not right now.
I was already starting.
Oh yeah, sure. So yeah, this is a one command line. You can actually use a Maven or Gradle command line to create for example, Amazon Lambda. So I already created some of the example here. Please hold in for me. Thank you. And then here's my app. Hopefully everybody can see that. So this is actually our book example. It's already available in GitLab publicly, so we're gonna show that, and then you can actually clone and use that. Some application running on Java 21, or some application running on Java 17, because Azure doesn't support Java 20 at this moment. And then, so that is a really different version of Java. Unfortunately, there is no Java 8. So sorry if you have Java 8. So Amazon, let me go to, this is a very simple app just for demo. I don't want to ruin whole today. So this is like a rendering application, some like a Pojo Java, and then just REST API. And here's the interesting part. You can see that the func annotation, this one annotation and Quarkus make your Java app portable and across serverless platforms. Amazon Lambda, Google Function, and Azure Cloud.
Yeah, so it basically externalizes all that specific code that you need to write for Amazon Lambda or for Azure Functions, and it kind of externalizes that into a Quarkus extension. So just by adding a Quarkus extension, for example, for Amazon Lambda or for Azure Functions or Google Cloud Functions, that functionality will kind of be living in that extension. And the func annotation will tell basically the Quarkus application, like, hey, this is supposed to be a Google Cloud or a function. And now when you do your compilation, it will translate that code into whatever is expected by that particular cloud provider. So that way your code becomes fully portable without rewriting anything. You just change the extensions, you swap the extensions, and then you can deploy exactly that same code to a different provider. Of course, there are some limitations to the Funky framework because the cloud providers, each function as a service has very kind of specific functionality too. So it can only go so far to cover all those specific scenarios of function as a service provider, but it tries to. And so, but you'll notice that for specific use cases that maybe you want to use from Amazon Lambda, maybe it's not covered by Funky. So you have to kind of weigh whether that's worth it to lock into that provider, or if you're okay with having a fully portable function.
That's a really good point, because when you go to, like, for example, Amazon Lambda, you can actually create like an Amazon Lambda API gateway based on HTTP or REST API gateway. So it will give you some more capability when you treat the function, some networking processing, something like that. So Funky created some abstraction and make it simpler, easier. And the best beauty of the Funky is make a portable your Java apps across platforms. But if you're looking for the more, go ahead.
Just real quick, is it injected in, or is it something like during the compilation you're just taking the code out, like injecting it, or is it some kind of visitor pattern or some kind of factory, or how's it being done?
It's something like an injection, not some get reading of some code. For example, the Azure function needs to implement a request handler, like some request mapping your Azure function. So Quarkus Funky actually wrapping up that kind of stuff. And then for developer, behind the scene, we're going to invoke the Azure API behind the scene. But in the application code level, you can just use a func annotation, and it automatically binding the original Azure API and the functions. Yeah. So this is kind of some function.
Yeah.
Yeah. So this Azure Amazon Lambda, just when I go, this is a Maven project, by the way. You can see that Java 21, and then the raised Quarkus version 392, and then we have the Funky annotation here, the Funky Amazon Lambda, which we make this using Funky. And then when I go to like a application properly, because sometimes people ask me, hey, Dan, you maybe hide some very complex configuration in some area there, but I show you nothing. I can actually remove this kind of stuff, because this is, I'm going to explicitly expose the endpoint URL starting with the API. The reason why we put this on, because the other function, we're going to use the same API URL. For example, Azure function, by default, they need to start with the API / something like that. So we're going to keep using same API across serverless platform. That's why I put in this one explicitly. And then nothing in there. So this is Amazon. And then I already deployed Amazon Lambda in advance. Here's my Amazon Lambda. And then you can see that Quarkus function, because Java 21 is a pretty bad networking here. So this is Amazon Lambda. So here is some of the role. And then if you have, some people actually experience the Amazon Lambda stuff, you just want to deploy your function Java into Amazon Lambda. Behind the scene, there happening a lot of stuff like API, and you would upload S3 buckets, and then some of the role IAM, and also sometimes the API gateway. A lot of things happening behind the scene to serve function. And you can also create like a template for cloud formation as well. So there are a lot of extra jobs for developer. You can read the documentation, you can run it, and then if you have failed, you can go to Stack Overflow or Amazon Expert, or you can go to ChatGPT, ask them. However, ChatGPT, oh, I'm sorry, I don't have no idea about that, and then, okay, go back to my normal life. So Quarkus Funky take care of all kind of this kind of stuff, rather than let you make some YAML file or property file manually. So let me go back to.
Can you scroll down just a little bit? Do you mind, just so we can see? Can I see what the method is?
Sure.
Okay.
Yep.
There's the hand. No, the handler. That's all.
Okay. Yep. And then back to here, and then let me just quick test here. So we actually put on so when you the packaging application, like a Maven package in the Amazon Funky stuff, it automatically generate magic some script here. This is Azure, this is Amazon, and then go to Target. You can have some magic script. It's automatically generated by Quarkus. You don't need to implement any kind of stuff, because Amazon allows you to use Amazon CLI, AWS CLI, to deploy and delete, update some of the stuff. So you don't need to worry about that kind of stuff. So you can just using this bash script to deploy application. So, and then it also provides invoke capability. And then let me try to invoke it. Literally start up my Amazon Lambda function. And now I got to approve the landing planet Lisa.
Any Star Trek fans here?
Okay.
Does anybody know the planet Risa, where they go and have fun?
Yeah, because we already print the payload JSON planet Lisa. That's why we happening. So when I go to, for example, Azure, and the pretty similar application, totally same. When I go to landing request, it's exactly same, the approval for landing. But in this case, you don't need to make like a payload JSON. You can just pass down your call command line, something like that. And I go back to web browser. Here's my Azure function. And then I have already deployed Azure function, just considering the still bad networking here. So it just takes some time. And then back to the application. And then let me try to find the right command line here. Here we go. So I'm going to clean up here. And then when I just click on here, let's go. And then it takes a similar time. And then now you can see that in the same result here, the approval for landing for planet Risa. Because it depends on which serverless platform are you using. Sometimes it takes a little bit longer and a little bit faster. And then last, the Google stuff is exactly same app here, HTTP stuff. Which PAM XML Azure, sure. Yeah. So Azure, like I mentioned earlier, Java 21 is not supported yet, so I'm using Java 17 and the same Quarkus version. And the only different thing is I'm using, this one, the Quarkus Funky HTTP and Azure Function HTTP. Yeah, so we've been working with the Microsoft, the Azure Function team closely recently. So we're gonna give more like engineering integration, Quarkus Function and Azure Function. So Microsoft actually contributed a lot to create the Azure extension on the Quarkus project. You can find a lot of stuff. We actually put in the loop in the display. And then one last thing, I'm gonna a little bit make it faster. So Java is the same Java app. You can see that in the resources. You see?
Quarkus supports Snapstar?
Yes. So Quarkus actually, you know what? Here's the tricky part. Amazon Lambda supports Snapstar, which is based on Quarkus. And then, so Quarkus build and deploy Amazon Lambda. The Snapstar is enabled by default, which means you don't need to turn it on. It already turned it on. You can actually turn it off if you want. And because Amazon Lambda based on Quarkus for snapshot, and then because of our engineering team, their engineering team working together a lot. Yeah.
You've got this landing details 3 different times now. Is it possible for me to create a jar file and say you figure out which one you want to put it in? Meaning I created landing details as in a jar and said, ship it to wherever you want to ship it.
Yes.
You have to rebuild it
Yep.
every time?
Yep.
You do have to rebuild it, yeah.
Yep. And then more like some more realistic practice, you can actually create the Lambda template like a YAML file and put in the packaging job file and whatever you define in there, like even Snapstar or any kind of resources you arrive to Amazon. So maybe there is more realistic, more real story in there.
Gradle CI/CD do 3 profiles.
Mm-hmm. Good point. So okay, this one, and I'm going to call, where is that Google Cloud? Here we go, and then, so here is the deploy using Google Cloud command line. This is the same command line to call, and then it takes some time because my Google function is scaled down already, and then you can do the same result. And let me go back to my web browser, and this is Google function using Java 21 and the Gen 2 type, and then you can see here. And then once you no traffic in a certain time period, in the function will be scaled down to 0. And then let me go back to slide to show. And then the last part, I'm going to hand over back to Kevin.
All right, so far we've been deploying our functions to the different functions as service providers. But, you know, at some point, you're going to want to build something around your application, right? So you may need to use a messaging system or a database or something. So, you know, so here, for example, with Amazon Lambda, we can see that, you know, like you probably want to create an API gateway and then maybe use SQS or Event Bridge, and you're back to being locked in, right? So we need to be a little bit careful about using the functions as a service, even when we can create portable functions. So we've talked about functions as a service, but actually serverless is going, you know, a little bit further than just these functions as a service these days. So with the advent of containers, we can actually leverage containers to
Question
yes,
over there.
you have a question.
Yes, sir.
Yeah, I only wanted to ask about, well, you have shown the usage of Quarkus in Lambda or function as a service, but running on top of the JVM.
Yeah.
Which would be the results if we use the native artifact going to the Lambda. So I assume the result would be amazingly better than.
That's a really good question. So I can answer that. For example, mentioned earlier SnapStart. So you can turn it on SnapStart by default, and then SnapStart and then native comparison on Graphian on Amazon Lambda, pretty much the same startup time. Even sometimes the SnapStart faster than native comparison. That's actually proved by Amazon people, dev routing. So, but here's the thing. So serverless is not only about startup time, because you also need to consume your resources, like files, size, and memory footprint as well. So if you only care about startup time, go for a SnapStart with JVM. Much easier debugging and implement stuff, right? However, if you will more care about like memory usage and then file, because the already start up and then deploy and then you use a networking as well as a file storage like a S3 bucket, it's all about money problem. So it holds kind of you holding your challenge, I would say go to native comparison. But just startup time, yeah, SnapStart and JVM better.
SnapStart is something from Amazon, right?
Yeah, only Amazon.
Exactly. So
Yeah.
If I use
Azure or Google, yeah.
So if I use Funky
Yeah.
and I go to native using Quarkus,
Yeah.
I will have better startup time in Azure.
All of them.
Yeah, always native is better. It doesn't matter Quarkus, Spring Boot, any kind of Java. It's a native comparison, executable, way faster and smaller than JVM. It's a most likely Golang stuff. Sure.
Excellent question, thank you. So let's move on to serverless containers, right? Containers give us a lot more flexibility in terms of building our applications. We're not tied to specific formats that the cloud providers expect. We don't even necessarily need to use the Funky API anymore. We can just use our regular Java applications and make them serverless, right? Ideally with Quarkus, so we still have the fast startup time and a better resource usage, but you know, really you could containerize anything. And then leverage serverless with containers. So of course, the different cloud providers are like, that's no problem. We can also provide solutions for that, right? So we have, again, Amazon, Azure, they have container instances and the different names for those. But of course, you have the same kind of lock-in, right? Because they're like, yeah, so use a container so you can write your code. You're not locked into the code, but then, yeah, but you also need to create an application gateway that's specific to Azure or AWS or whatever. and then have some endpoints, and then tie into some of their service and everything. So yeah, I mean, I'm not saying don't use it. I'm saying this is something that you need to consider when you're going to use serverless containers outside of Kubernetes. Now, if you go the Kubernetes way, like I showed before, right? Kubernetes allows you to go pretty much to any cloud provider. They all support it. You can use, an OpenShift, of course, but you can also use one of the Kubernetes provided by those providers, or you can deploy your own, right? And then on top of that, there's a really cool project called Knative, which enables serverless on top of Kubernetes. So it will scale down your containers to 0 when there's no requests coming in. So if you're familiar with auto-scaling in Kubernetes, because Kubernetes out of the box can also auto-scale, but is by default based on CPU and memory. And so it's a little bit slower to scale because it needs to see that there's actually a spike in CPU or memory, and then it'll scale up or down. But Knative actually looks for the requests that are coming in. And so by kind of making a little bit of a front in front of your requests before they go to your pods, it can notice, well, there's no requests coming in, so why are you using any resources? We'll scale down your containers to 0. Is there a lot of requests coming in? Scale up to whatever you need. And so you can use just the resources that you need in that moment. So that's one of the capabilities of Knative. So it enables serverless for containers. It also makes it easier to deploy containers, so you don't need to worry about creating deployments and services and exposing those services. Actually, when you deploy a Knative service, it kind of has that functionality encapsulated, which makes it a little bit easier to work with containers. You can actually create a Knative service from the Knative CLI, and it will kind of take care of building the container and everything too. And so it can do automatic scaling, and you can use it not just in the cloud, but also on-premise, right? On-premises, because you have your Kubernetes potentially running on your private data center as well. And it also supports event-driven architectures, which we'll visit in a little bit. So just to give you an idea of what advantages serverless can give you in terms of your node utilization. So you have, different, a Kubernetes cluster can be spread across different nodes, different servers, right? And so if you think about it on the left side, this is, we're provisioning enough resources for receiving a lot of traffic in a non-serverless way. And on the right side, you can see kind of with serverless, we don't have as many instances of our applications deployed. And then as traffic goes in and out, you can see that it dynamically scales up and down, and you're actually using less utilization of your node, and that allows you to use actually less servers, less nodes, and potentially allows you to save some money and maybe even energy. So that's a nice advantage of using serverless as well. So if you use the Knative CLI, this is an example of how you can create Knative functions. So it's fairly straightforward, right? So you do kn-func create, and then L for library. So in this case, library Quarkus can also be Spring Boot, or it can be Node.js or whatever. And then a name of your function that creates your Knative function. And
the runtime, you can choose Java, like a Quarkus Spring Boot, and JavaScript, Node.js, and Python, Go. There are several runtime you can do that, because Knative ultimate goal is to serve all multiple polyglot runtimes on Kubernetes as serverless.
Right, exactly, because it's a container, right? And then to deploy your function, you can just do kn-func deploy. It'll package up your container into a container and then deploy it to your Kubernetes as a serverless application that by default scales down to 0 when there's no usage. You can configure it to scale based on your demands. So we've evolved, right? So we've evolved from function as a service to using containers, Kubernetes, giving us a lot more flexibility, because now we can leverage the Kubernetes ecosystem to tie in different services, messaging systems, and everything. So we can actually go further with serverless into leveraging it for applications that have that need to be integrated different services with different components, and then perhaps even tie in some state into all of that as well. So Knative has the serving component, right, that allows you to scale up and down, and it also has an eventing component allowing you to integrate events into your systems to flow traffic between your different services. So it has components that you might be familiar with if you've used messaging systems in the past, like brokers and different event sources. So the Knative eventing component relies on the cloud event specification. Who's heard of the cloud event spec? So we have a few people. The cloud event spec is actually really interesting because we have different messaging systems use different protocols, use different formats, and so it's a little hard, right? Because it's very easy to get locked into one specific messaging system, and then maybe you're using a more traditional messaging system, and then, well, now we want to use Kafka, and then, well, but now we want to use Pulsar or whatever, making you have to do quite a bit of migration because the protocols are different and everything. So the idea with cloud events is to have a common specification for events, making it protocol agnostic, so you can specify in your payload what protocol is supposed to be used, what the format is of your messaging. So Cloud Events is a really interesting project that is supported by Knative, and actually by Google Cloud Functions as well, but not AWS or Azure. So the kind of the usage pattern of Knative eventing is that you have an event source, and then, of course, the Knative service that receives those events. And then you can make it a little more interesting by adding, for example, a channel in between that holds the state of your event, and then you have potentially multiple subscribers that receive those events from your source. And then you can also even have a Knative broker allowing you to filter based on what messages, what events are you interested in for this subscriber, and which events are you interested in for that subscriber. So it's a pretty nice system, which is fully cloud native, running on Kubernetes, so in using the cloud event spec, allowing you to have a very kind of cloud agnostic approach to not just serverless, but actually the whole kind of eventing system around that, which that makes sense with serverless, right? Because you want to have events that trigger whether you need to scale up or down. So let's do one more demo as we're wrapping up here. So this is a demo that I created that you'll participate in, hopefully, to vote for your favorite IDE. So I listed 6. So IntelliJ and VS Code, of course, and then Eclipse, of course, and then Vim. Sorry if there's any Emacs, you'll have to vote for other. And then we also have OpenShift dev spaces because we're, of course, a little bit biased towards OpenShift. So the way that that I've over-engineered this demo is, you have an UI component, and so it's also serverless. So this just sits there and has 0 instances right now because nobody's hitting this application. And as soon as I share the QR code, you'll go to this application, it'll wake up, and it'll start scaling up based on how many people are participating. And then you can vote as many times as you want, and I encourage you to vote a lot of times, because the more you vote, the more requests are going to be sent to this kind of ingester component, which is going to receive the events, and is going to scale up based on how many times you're voting. And then in this case, it's using Kafka. That could also be a Knative channel. In this case, we're using Kafka. And then we have another component that's listening for those events and then inserting it in the database or updating the database, which is then being read by our UI component to update the results on the fly. So I think we can try it and see how this goes. Hopefully the QR code works. Somebody can confirm that they see okay, and then you can go ahead and start voting. And Daniel, if you want to show us the actual application running, in this case in OpenShift.
There's no spinner on the button.
Oh man, terrible UI, right? Yeah, and apologies for that. Yeah, I'm terrible with UI, so that checks out. Yeah. Okay, so
Which project? It's
yeah, so go to the Camel demo project, and then here we can see our different components.
right.
Yeah,
So why
should
they-
be okay.
Why is all right.
And then if you can show the results on the side as well. So you can see here, you see those little circles around the application, and they kind of dance around based on how many times you're voting, because it's going to go scale up and down based on if you're voting a lot, it's going to create more pods to handle all the traffic, and then scale down if you're not voting a lot. So I kind of tricked the system to scale very fast. So I set it to scale, so to not accept concurrent requests per pod. So every time there's concurrent requests, it's going to create more pods, which again might not be the best approach, but it really shows kind of how fast with Knative you can scale up and down. So you can see, if everybody at some point would stop voting, then we would see that it scales all the way down to 0. What are the results so far? IntelliJ is winning. VS Code equals. Oh, look, we do have 300 votes for OpenShift dev spaces.
What are the others?
What?
Yeah, 700.
That's the Emacs people.
Okay. All right. Good
All right,
for
so,
you.
So you can see it scaling up and down, and maybe if everybody stops voting for a minute, we're going to see that it's going to scale down, and then at some point it's going to just go to sleep, and then
Just like
it'll
a
just wait.
serverless behavior.
Right. Yeah.
Okay,
There we
scale
go.
down
You
to
see that it's scaled down to 0, and if you now start voting again, we'll see that it goes up again. So that's the idea with serverless, of course, right? So I'm going to do one thing here. Hold the mic. I'm going to cheat. Yeah.
Yeah, voting on like OpenShift dev space more than 10,000.
Yeah.
So in the topology view, you can see how to differentiate a normal container pod and serverless here. You can see there's some boxes here. This is deployed as a serverless and based on Knative. So OpenShift cluster actually provide the built-in operator. So you can use some OpenShift serverless operator built-in Knative. So you could just click a few times and deploy to serverless. And then after that, whenever you deploy application, you can choose like a normal app or a serverless. And then we already deployed the front end and then some of the back end as a serverless. And then PostSQL is not serverless, of course, database. And then here we go. You don't?
I'm trying. The demo gods are even messing with my laptop. Let's see if it connects. Okay. So keep an eye on the scaling, and we see that it's really scaling pretty quickly, right? And look at OpenShift.
Yeah,
look
here
at
we go.
OpenShift
Yeah.
dev spaces. All of a sudden, wow, it's so popular.
Yes.
Yeah.
Vastly going down.
Yeah. So you can see, yeah, like how many pods are being created.
Yeah, here 19. It was goes up like
Yeah.
89,
Right,
something
yeah.
like that. Yeah.
Anyway, so I think we can go back to the slides
All right.
to wrap it up.
Sure.
Okay, so of course, no talk these days is complete without mentioning AI, right? So we're actually not going to talk about AI, but actually serverless makes a lot of sense for AI type of workloads too, where you want to scale up and down based on what you're calling and how many resources you're using. So what we did is we posted here one link to a case study that's using serverless with AI. So if you're interested in this, definitely give that a read. It's really interesting. But yeah, in the interest of time, we'll wrap it up. So of course, like we said, cloud providers, they offer a lot of really cool stuff. There's a lot of really cool services. But of course, so be mindful of how much you're going to get locked into one of these services. So Serverless itself is much more than just functions as a service. So we showed you how to use it with containers. In this case, we used Quarkus, and actually in the demo we used Apache Camel as well. So Camel with Quarkus for the integration between the different components. So I'll share the source code of that as well. And then use open source when you can, and proprietary services when you must, right? That's kind of obvious. And I would say overall, in terms of open source, sometimes I get the feedback like, yeah, but this open source project doesn't have X, Y, or Z or whatever. Well, this is the great thing about open source. We can all contribute to it, right? Or doesn't necessarily mean you need to write the code, but at least let the maintainers of these projects know that this is a feature that you're interested in, or this is something that doesn't work the way that you would like to. So yeah, just a quick shout out. So at Red Hat, we also are encouraged to write books. And so, like we said, we're writing a serverless Java book, which isn't available there yet. But hopefully it will be soon. But there's a whole bunch of books that you can download for free. So that's pretty cool that Red Hat sponsors those books and makes those available to download. And
going next. Oh yeah, so like Kevin mentioned earlier, so we are almost ready to publish all these access program with the many. So it will be available online, and then you're gonna just take a look at the first 3 chapters. So including that example, yeah, stay tuned. Just follow us, and then we're gonna keep you posted what's happening in the next couple of months. And then we have a bunch of great sessions. Less for today and tomorrow. So for me, I'm gonna show the 1-hour live coding just right after this, and then tomorrow I'm gonna really talk about Java 21 and virtual thread and how to make it better performance on application on Java stuff. And there are also very great session ready for tomorrow. And then one more thing. So a lot of Spring developers asked us, hey, so why should I use Quarkus rather than Spring Boot? And then there could be many answers. So first thing is to read this book. You can download it for free and from the developers@redhat.com. But also we prepare paper books, really limited paper books here. And then we're gonna book signing tomorrow to 2:40 right after my session. I'm was one of the part of the authors as well. So yeah, feel free, stop by Red Hat booth tomorrow to 2:40 p.m. and we can prepare some of the book signing and the paper book as well. And thank you so much. And if you have any question, go ahead.
And this QR code is for the slides. So if you would like the slides with the links, then they're available here. But any questions in the meantime?
Right. Thank you so much.
All right, thank you.